For this tutorial, I am going to cover 3 different types of pointers, and they are wild pointers, null pointers, and void pointers. Let's start with wild pointers. Now, what is a wild pointer? So a wild pointer is basically an uninitialized pointer. When it's uninitialized, the behavior of it is undefined because it points to some unknown memory location. And this may cause the program to crash or to behave badly. Let's take a look at an example here on the code section on the left-hand side. So typically when we create pointers, we have to initialize it. So for example, let's say I have an integer variable called num, and let's just say that that num has the number 23. And let me declare a pointer, and I'll just call it PTR. And that pointer is assigned the address of num. And if I print PTR with a dereference operator with the asterisk, I would get 23. Now I can change PTR. I can say star PTR and assign it a different number to 30. For me to change the value, I would have to add the dereference operator, which goes to the address of num and changes the value from 23 to 30. And if I print it, I should get 30. Now, a pointer becomes wild when we leave it uninitialized. So let me remove line 12 and let me remove the assignment. And notice here on line 12, I've declared a pointer, but it's uninitialized. A pointer is an address variable, so it holds an address. And by leaving it uninitialized, it's not holding a specified address. Now, if I try to include line 14, assign 30 to it, this pointer is going to try to access some unknown memory location. This can crash our program, or it can make our program behave badly. So let's run this and see what happens. Notice how it returned a negative number and it gave us an address location. And so this program is behaving badly. We can easily avoid the creation of wild pointers by initializing our pointer to some valid memory at the time of declaration, or we can set it equal to null. Now, what exactly is a null pointer? A null pointer is predefined in macro with a value of 0. And since 0 is not a valid memory address, we can consider null to be used for nothing or for no address. In other words, null allows the compiler to know that the pointer does not have a valid memory address. And it's also considered best practice to set your pointer to equal null so that you can avoid the issue of creating a wild pointer or your computer accessing another memory location or an invalid memory location, which leads to bad behavior. So let's go over to the code section so I can demonstrate the null pointer, and let me remove line 14. I'm going to print null pointer, but this time I'm going to use %p as a format specifier, which is used to print the memory address in hexadecimal format. And let me remove the dereference operator because we're not pointing to a location that has value. And let me go ahead and print it. And notice how you get zeros. Now let me print null itself so we can compare the values. There it is, null is 0. So in short, the value of the null macro is 0, and the value of the null pointer is also 0, which means that it's not pointing to any valid memory address. And finally, let's talk about void pointers. Now, void pointers is a pointer that is not associated with any data type. So this means that it can point and typecast to any data type. It is also known as a general purpose pointer or a generic pointer. I haven't covered dynamic memory allocation yet, but both malloc and the calloc function returns a void pointer. Now let's take a look at this code on the left hand side. On line 12 I have an integer variable with a value of 30. And on line 13 I declare a void pointer and I assign to it the address of our variable num. And here I'm going to print it, and notice how I am typecasting this void pointer. And the reason for that is because you cannot dereference a void pointer. And with order of precedence, you have to typecast it first and then dereference it. So let me print it, and we should get the value 30. And there it is. And so let me delete this typecast and watch what happens when we try to dereference a void pointer. Notice how we get an error that says invalid use of a void expression. And so we have to typecast it, and then we'll get the output of 30. Typecasting is also important because data types have different sizes. We have to tell the compiler how much memory is needed. In other words, the compiler has to assign the memory allocation for the dereference void pointer. For example, a char only takes up 1 byte, an integer takes up 4 bytes, whereas a long or a double takes up 8 bytes. Moreover, we don't use pointer variables to store memory only. We also use them to dereference the addresses so that we can access and modify the values stored in those addresses. Finally, it is also important to note that we cannot do pointer arithmetic with void pointers. In summary, a wild pointer is an uninitialized pointer, and it points to some arbitrary memory location that may cause the program to crash or behave badly. So to avoid wild pointers, it is best to initialize it to null, and this is called a null pointer. A null pointer is basically a macro that has a value of 0. It points to nothing, and it initializes the pointer variable when that pointer variable is not assigned to any actual memory address. It can be passed to a function argument when we're not willing to pass any actual memory address, and it's also best practice. And finally, a void pointer is not aligned with any data types. It points to the address of variables. It is known as the general purpose pointers or generic pointers. Both the malloc function and the calloc function return void pointers, and you also have to typecast it when printing. Moreover, you cannot do pointer arithmetic with void pointers. So I hope that this video has helped you understand wild, null, and void pointers. Thank you for watching.